Number 10. First, what do these expressions refer to? They refer to these segments that are parts of diagonals. So this parallelogram has diagonals. How do we know it's a parallelogram? It doesn't say, because the top and the bottom are parallel, designated by the arrows, and the left side and right side are parallel. So it's a parallelogram, and these are the diagonals, and these expressions represent pieces of the diagonals. So now we need to ask ourselves, what do we know about parallelograms? If we look at one of the outlines from class, if we have a parallelogram, then we know several things are true. By definition, opposite sides are parallel. The diagonals bisect each other, which means cut each other in half. The opposite sides are congruent, left and right, top and bottom. Opposite angles are congruent. And consecutive angles add up to 180, like 1 and 2's measures add up to 180, 2 and 3's add up to 180, etc. All right, well, looks like in our picture we're dealing with diagonals. And since we know it's a parallelogram, the diagonals bisect each other, which means cuts each other in half. So we know that the green part is equal to the pink part, and the yellow must equal the blue, because these are the two halves of this diagonal, which has been bisected. And green and pink are the two halves of this diagonal, which has been bisected. All right, so the yellow half is equal to the blue half, and the green half is equal to the pink half. Great question, number 10. How do you solve this? This is a system of two equations. Each equation has x's and y's, so we can't solve any of them alone. We'll have to use either the substitution method or the elimination method to solve this system. I'm going to be upfront. Solving a system actually will not be something that we ask you to do on this Chapter 7 Cloudis test. But nonetheless, from algebra last year, you did learn how to solve systems like that. So for the rest of this video, I'm going to walk through how you would solve the system in both the elimination method and the substitution method. All right, so on the left side, we'll do the substitution method, and on the right side, we'll practice the elimination method. In the substitution method, you can take either of these two equations and choose any one letter and get it by itself. So I'm going to choose the first equation. I'm going to isolate the y. So we'll subtract 2x from both sides, which means on the left side, 2x minus 2x is 0, which means we have just y remaining. And then on the right, we have 11 minus 2x. And as soon as you get a letter by itself, you're done with step 1. And let's go ahead and circle what that letter is equal to. Next, we got that from this equation. Now we're going to substitute, and that's why this is called the substitution method, this expression in for y in the other equation, which goes right there. So y equals 11 minus 2x, but when you put 11 minus 2x into this equation in place of y, then we have x plus 3 times 11 minus 2x equals 13, and we go ahead and solve that. Distribute. Combine your like terms. Subtract 33 from both sides. Divide both sides by -5, and x is equal to 4. And once you have x equals 4, come back full circle to the circle, and we know that y is equal to 11 minus 2 times x. And x we just figured out was 4. So y is equal to 11 minus 8, which is 3. So x is 4 and y is 3. All right, let's see how we can do the same thing, solving the system using the elimination method. With the elimination method, you focus on either the x's or the y's, but not both of them, just one of them. Let's focus on the x's. What would we have to multiply, let's say the bottom equation by, so that the number of x's would be -2x's, the opposite of this many x's in yellow? We'd have to multiply this equation by -2. So multiply the bottom equation, both sides of the equation, the left side of the equation and the right side, times -2. Let's rewrite both the top equation and the bottom equation after we do that. This is our new system. The bottom equation changed by a factor of -2. And now that you've done this, notice these terms, if we added them together, would cancel out. They would be eliminated, and that's why this is called the elimination method. So on the right side, we have 11 plus negative 26 is negative 15. And on the left side, negative 2x and 2x is 0. Y and negative 6y is negative 5y. So when we divide both sides by negative 5, y is equal to 3. And then we just need to find x. And you can just come back up here and say, when y is equal to 3, what is x equal to? So subtract 3 from both sides, we get 2x is equal to 8. So x is equal to 4. Just like when we use the substitution method.